Hey guys, I welcome you all to UPSC 360. So in today's class, we'll be delving into this topic of endogenetic and exogenetic forces, which are a kind of geomorphic processes, right? But since this is too long, so what we'll do is we'll just cover up in two parts. So in the first part, we'll be focusing on what endogenetic forces means. Now, first of all, since these are the types of geomorphic processes, so let's see what geomorphic process means. See, geomorphic process is any kind of process which leads to the formation and alteration in Earth's surface. Now, how does it happen? It happens due to interaction between the physical and the chemical component of Earth and natural environment, which further results in the producing of landforms, right? And see, these natural environment, these whatever are the variables that has been determined by these geomorphic processes. Those variables are geology of that particular region, climate of a particular region, vegetation and waste level of a particular region, right? Because these are the factors which further determines that what kind of landform will be developed in any particular region, right? So basically geomorphic process is any process which results in the earth movement. Now if you are confusing this earth movement, that's what is this earth movement. So see, basically there are two things, there are two keywords which we actually learned. The first one is movement of earth and the second one is earth movement, right? So let's delve into these two topics separately. What is movement of earth? See, when we consider movement of earth as an entity, say for example earth is revolving around the sun, right? So in this we are considering earth as an entity, right? So that is, in that sense, we'll call it movement of earth. Now what is earth movement? See, earth movement is basically the movement of any part of earth within itself. Say for example landslide, we have heard about it, right? So in what happens in landslide is some amount of land falls downwards, right? So what happens is this amount of earth is the entity within earth, right, which falls, which moves from one place to another place, right? So that is the earth movement. There are different examples. Of course, we have dealt this example, landslide. Second example, we can talk about plate tectonics, right? So what happens is plate tectonics, the two plate either diverges or converges, right? So these are the movement of earth within itself, all right? So these are the basically good examples of earth movement as well. So you can actually observe these into this. So anyways, let's focus now on geomorphic processes. See, there are two kinds of geomorphic processes. First is endogenetic forces, second is exogenetic forces. Pardon me. So endogenetic forces are those kind of forces whose energy is been supplied by the Earth's interior, like radioactivity, like displacement of molten magma, which results in the formation of volcanic mountains, right? Like expansion of earth surface, right? Like contraction of earth surface. So these are basically endogenetic forces, because in these we get the energy from within earth, right? And what is exogenetic process? See, whenever there is erosion, say for example by the application of wind, by the application of glaciers or fluvial erosion, by the application of air, right? So what happens is, in exogenetic forces, out of the earth some forces are acting and it results in the movement of earth. The clear difference is very much clear, I guess. All right. So also in endogenetic forces, it leads to creation of land. That's why endogenetic forces are also called creative forces. But on the second hand, in exogenetic forces, it leads to the destruction of land. That's why it is called destructive forces, right? Endogenetic forces are of two types. Either they are horizontal or vertical. Example, the formation of mountains, right? Mountains can be said to be it is said to be the combination of both vertical as well as horizontal movement, right? Earthquake, it is a displacement which is happening within the earth surface, right? So it is a vertical movement, all right? So there are various movements which happens under the endogenetic forces. Similarly, in exogenetic forces, as we have learned that this is destructive forces, means it results in destruction of land surface, like a mountain is there, right? And fluvial erosion leads to degrading of mountain, right? It decreases the height till this, right? So what is happening? It is destructing the land surface, right? And the examples are weathering, erosion, etc. The actions of exogenic force results in wearing down, that is degradation of relief features happen, right? See, say for example, firstly the mountain is like this, right? After degradation the mountain is like this, right? So here the degradation has happened, but this portion of earth is being deposited somewhere other else. So there what is happening? There aggradation is happening. Alright, so both phenomena are happening simultaneously, and the phenomena of scale or series of studies has been conducted. So these degradation, these aggradation, these togetherly they are known as gradation, right? Because either there is reduction of land surface or there is addition of some earth material in any particular place, right? Now let's focus deeply on what endogenetic force means. See, endogenetic force, under this we'll read two movements. First is slow movement, which is also called as diastropism. Second is suddenly movement. So let's first delve into what slow movement means, diastropism. See, basically, uh, wait. Yeah, there are two types of slow movement first of all. First is vertical, second is horizontal. Vertical we call it epirogenetic, or we also call it continental building forces. Horizontal we call it orogenic or mountain building, right? See, first is endogenetic force, that is slow movement, which is called diastropism. Under it we'll read what this horizontal forces means, right? See, horizontal, in horizontal it is basically mountain building force. What happens is orogenic, we call it orogenic, right? So orogenic in itself, oro means mountain and genic means origin, means it is the origin of mountain due to the horizontal intrusive forces, that is endogenetic forces. So what happens is, the horizontally, say for example this is the earth, right? So if there is horizontal forces applying, then it will act along tangential form, right? So what happens is there occurs tensional forces. Like, see, this is the first example in which the tensional forces are happening. So both the crust are taken apart, right? Means it results in the formation of faults or rupture, right? Or in the second form, in which there is compression force acting. This is also a horizontal force, but this is compression force happening, in which one plate is getting subducted under the other plate, right? So this often results in the formation of folds. So basically these are the categorization of horizontal force which we actually observe under the endogenic force, right? Next is vertical force. In vertical force we call it epirogenic movement. Epiro means land, genic means origin, right? So vertical movement leads to the formation of land. What happens is, this we can put forth under this Arthur Holmes thermal convective current theory, in which he has said that there is convective current which are occurring within the earth crust, right? So there what happening is, this is a kind of vertical movement which we actually observe, in which upliftment and subsistence of continental mass happens through upward movement and downward movement, right? Also there are acting tensional forces which also results in the formation of faults in this region, right? See, these faults are further happening due to, of course, the horizontal forces, but again, both the forces are acting simultaneously, I would say, right? So it results in the formation of crustal bending. See, basically crustal bendings are also of two ways. First is warping, second is folding. Warping means, see, warping is basically when the folding is happening on a large area, right? Then that is called warping. Basically, it is of two types. First is upward, second is downward. This is upward, this is downward, right? And when these are happening at a very large area, then it results in the formation of broad warping. All right. Second is folding. In folding, basically what we happens is, compressive horizontal forces happen, which results in the formation of converging movements, right? And since, say for example, both the sides there are compressive movements are happening, then what will happen is that there will be squeezing of crustal rocks, which will further results in the formation of folds, right? So this is what happening. Now, well, if we actually observe the basic difference between warping and folding, then what warping means? Warping in which crust is warped, that is either it is raised upward or it is raised downward, right? And in folding, basically bending of rocks happens. So this is the basic difference between warping and folding. All right. Next, folds. Let's see upon folds. See what folds are. Basically, this is the kind of fold only which we have shown in the picture, right? So what happens is it further depends on the characteristics of rocks. If rocks are soft and elastic, then the folds is quite intense. If the rocks are hard and inelastic, then the fold will be less intense. Now, I've given two pictures, right? So you just compare it, these both pictures, and tell me that in which case the rocks are quite hard and in which case the rocks are relatively soft. So you will find that then in the very first case the folds are relatively not that intense as compared to the second case, right? So we can easily tell that in if we compare this both the cases, then in the second case, since the folds are quite intense, so the rock here will be relatively soft and elastic as compared to the first form, in which the rocks are relatively hard as compared to the second instance, right? So these are the results in the formation of fold. See, this is also fold. So this axis is called anticlinal axis, right? And this axis is called synclinal axis, right? This is called anticline, this is called syncline, this is called these are axial planes basically, and it is axial plane of anticline, it is axial plane of syncline, right? So when there is anticline, syncline, see, as we can clearly observe, anticline, syncline, anticline, syncline, anticline, syncline. So if it makes a fan-shaped structure, then this totally, see, this is the upward fan-shaped structure, this is the downward fan-shaped structure, right? So this upward fan-shaped structure is called anticlinorium. This downward fan-shaped structure is called synclinorium. All right. So these are quite terms which we should actually remember. Now comes that what are the fold types. See, basically on the amount and intensity of compressions, fold types are determined. The first is symmetrical fold, asymmetrical fold, isoclinical fold, overturned fold, chevron fold, recumbent fold, right? So nap fold is also there. So let's discuss what are these folds all about. We are discussing. See, the first one is symmetrical fold, in which, see, this is symmetrical. First one is symmetrical fold, right? So what happens is in this fold, limbs of the fold must dip at the same angle away from the fold axis. See, this is the fold axis and these are the limbs, right? So the angle of first limb and the angle of second limb are quite symmetric, right? So that's why it is called symmetrical fold, right? Next comes asymmetric fold. In asymmetric fold, the limbs of the fold must dip at different angle. Say for example, this angle and this angle is not same. All right, it's clearly you can observe it in diagram as well. So in this scale it is called asymmetrical fold. All right, next is third one, that is overturned fold. In this, the limbs of the folds are rotated past vertical. See, earlier the angle were not same, but in this what happening is the limbs, it is just rotating past vertical, right? It's quite rotating. All right, so in this case it is called overturned fold. All right, the fourth one is recumbent fold, in which action plane tilt near to horizontal या फिर horizontal. See, earlier this was the case, right? This was overturned fold. If we fold this overturned fold furthermore, then this axis, it will be almost horizontal to the surface of the earth. So in that case it is called recumbent fold. It is clear? All right. Next is nap fold. See, what happens is this type of fold has already happened. Say for example, this fold has already happened, right? Further, say for example, if along this plane compressive forces are acting, then this will break apart, right? and earlier this will now shift to this position. This will be new position. This will be new position, right? So in this case, as we can say in this picture as well, so thrust is in this area, right? So that's why these kinds of folds are called nap fold. All right. Next is isoclinical fold. See, earlier there is quite a small difference between isoclinical fold and recumbent fold. In recumbent fold, we have seen that this is big. This limbs are become horizontal, right? But in isoclinical fold, they are becoming parallel, not horizontal. They are not horizontal to the surface. But yes, in the case in which they are parallel to each other, this limb, and this limb, then that will be the case of isoclinical fold. Is it clear? Next is monoclinical fold. Monoclinical fold in which we get these kind of fold. See, clear? It is monoclinical fold. This is very quite simple. Chevron fold. In chevron fold, this happens like this, right? The crest will happen like it will take a shape of absolutely intersection kind of angle, and this is also happening like V-shaped, right? So in this case, I mean, these kinds of folds are called chevron folds. Next is fan fold. Fan fold in which the anticline will resemble the fan. See, what happens is earlier, our ancestors, probably you have also used these kind of fans, right? Even now also, these kind of fans are there, right? So that's why this, if we, put a handle here, then it will resemble a fan, right? So that's why these are called fan fold, in which the anticline looks like this fan type of shape, and syncline also looks like the fan shape, right? So these kind of folds are called fan fold. Open fold, in which the angle is between 90 degree and 180 degree, right? Say for example, see, this is the 90 degree, right? But the fold in which the angle is between 90 and 180, then that is called open fold, right? But in closed fold, the angle must be less than 90, right? See this, right? So this is closed fold. Now these can be categorized under chevron fold as well, right? See, chevron fold. Okay, next is plunge fold. See, what happens is, say for example, this is the structure, right? And if by this plane you cut this structure, then you will probably get the shape like this, right? But what happens is, due to the endogenetic forces, sometimes what happens is this axis changes like this, right? So what happens is, if you cut like this, then you get quite this type of cross section, right? So this cross section view is not important, but this kind of fold is quite important, and this is called plunge fold. So in this we have covered this horizontal part. Now next comes is faulting, right? See, this we'll discuss tensional folds, faulting. First we have already discussed folding, compression forces. Now tensional forces, that is faulting. What is faulting? So in faulting, what happens is the crustal rocks fractures, right? In which the rocks are displaced along the plane, like this. Earlier the plane was like this probably. Now along an axis, this this wall has shifted downward, right? So it's happened due to the creation of the fault over here, right? And this is the theoretical diagram, but in practical life you will see this is also fracture that has happened in this land. Earlier the land was probably like this, but this whole section, this is along the fracture plane, this land has gone down, right? So this is the practical life example, practical life picture of it, right? So more you can get in through this picture as well, in which it falls like this. All right, earlier this both were in same plane, but along the fault plane this landmass has down thrown. All right, so what is dip angle? See, earlier this was the foot wall and this is the hanging wall, right? Hanging wall comes down. All right, so the angle which this hanging walls, this plane makes with this fault plane, that is called dip angle. All right, so in this case, of course, this is the dip angle. Is it clear? Because earlier this portion was above like this, right? But along this angle it has fallen, right? So this angle is called dip angle. So in this case as well, guys, this is the dip angle, right? Here the water is stored. So I mean, this is just to show, this is just to make you visualize the facts that what is dip angle, right? Now, in this case, it is called foot wall and it is called hanging wall. It is very much clear. Now, what is the distance between this much and this much? It is called heave, all right? And from here to here, this distance is called throw, right? So just remember it. And whenever they're occurring, I mean, like faults and all, so there are formation of horst as well as graben, right? This is kind of rift valley formation that happens due to the faulting activities. Now, what are the types of faults? See, it can be classified into two types basically. The first one is dip slip fault. The second is strike slip fault. Dip slip fault happens when there is vertical movement like this. Either it goes downward or due to the compression force, it goes upward, right? But it is happening in a vertical motion, right? Alright, so in this case it is called dip slip fault. In the second, that is strike slip fault, it is happening horizontal movement, that is one block slide past the other block. Alright, so now also the question arises that what are the types of fault? See, the types of fault, the first one is normal fault, in which the hanging walls slips down relative to the foot wall. This is the foot wall, this is the hanging wall, right? And this hanging wall is slipping down relative to this foot wall, right? And it occurs due to the stretching of land, right? Means the land is being stretched at both other directions. That's why, you know, these are slipping down past each other. The throw, that is the vertical component of the movement, is quite large. This is what we have discussed. See, this is the throw we have discussed, right? So in this case, vertical movement is quite large, right? And that's what we can actually observe it over here in normal fault as well, right? And there is occurring vertical displacement. But in reverse fault, what happens is, earlier in normal fault, these both blocks were taken apart from each other, right? Earlier. But in reverse fault, the compressive forces acting most, right? Means it is absolutely opposite to the normal wall, in which hanging wall rises relative to the foot wall. Earlier it was downfalling, but in this case it is rising, just because of the fact that compressive stress is more on action, right? That's why in this case also there is vertical displacement. Next is strike slip fault. Strike slip fault, the best example is USA's San Andreas fault, right? So what happens is, one block move past the other block, right, in which the rock stratas are displaced mainly in horizontal direction, which is parallel to the line of fault, and it is called lateral fault or transcurrent fault, right, in which horizontal movement is happening. Next is step fault. What happens is, in earlier normal fault we have read that one block is foot wall, it is hanging block, right? But in steps fault, right, same thing happens, but step like formation happens, right? That's why we call it a step fault, right? Because there are formation of parallel fault planes, and there are a number of faults which we actually observe. It is also kind of vertical movement which is taking place, but it results in the formation of features which is step like features. Next is tier fault. Tier fault is also known as transform fault, which we have already discussed about it. So I don't think that with this we have to again read it. But next is very important. This is called hinge fault. In hinge fault, what happens is, this is the hinge point, and around which this slip happening. See, this is also this is the hanging wall only, but this hanging wall movement is on both direction, that is on this direction as well, on that direction as well, right? Because it is being hinged from a particular point, right? So that's why these kind of faults are called hinge fault. Next is rotatory effort scissor fault. See, scissor, what is scissor? It is, in Hindi we call it कैंची, right? So in scissor, by scissor we cut clothes and all, right? So what happens is, scissor, if we bring this closer, then this goes apart, right? Or if this gets closer, then this goes apart, right? This is the same thing happen. Okay, so same thing happens as well here as well. This is the hinge part in middle, right? And it happens like scissor only, right? That's why it is called scissor fault. Next is ring fault. Ring fault, it happens at a place where the magma activities are quite large, what happens is there a goal, I mean there is a circular patch of land goes down, right? So these faults are called ring faults, right? So with this, we have covered the slow movement, that is diastrophic movement of endogenetic forces. Now let's come to the sudden movement. Sudden movement we'll read in next class, because there are different other chapters which are absolutely dedicated to earthquake and absolutely dedicated to volcanism. So on that very classes we'll read about sudden movements. But with this, endogenetic forces comes to an end, it is covered. Now next comes is exogenetic forces, and this exogenetic forces will cover in the very next class. So stay tuned in then. Bye bye, take care, and thank you for listening to the whole video.